looking at the bell work, if we take our original ordered pair, and every time we're going to be coming back to this one. Original ordered pair is at -1, 4. So right here. If I take that ordered pair and I move it 2 units to the right, which part of my ordered pair, which number, the x part or the y part, is going to be affected by that translation of moving it left and right? The x part. So this is going to affect just the x. Excuse me. So I have -1, 4. You said it's going to only affect the x. If I'm going to the right, would that be the same as adding or subtracting? Adding. Moving to the right would be adding 2. And so my new point would be what then? 1, 4. What about if we move 6 units left? Is that going to affect the x or the y? The x. Anytime we have a horizontal translation, it is going to affect the x. We're going back to that original point, -1, 4. If I'm going to the left, would that be the same as adding or subtracting? Subtracting. So I have -1 minus 6, since I'm moving to the left, 6. -7, 4. What about if we have a vertical translation of -5 units? Vertical translation is going to affect which part? The y. Always going back to that original point of -1, 4. If it is a vertical translation of -5 units, would I add or subtract? Subtract. I'm going to subtract 5 units. So that means my new ordered pair would be moved to -1, -1. All right, 2 more to go. We have a reflection across the x-axis. As I'm thinking about my original point, x-axis is right here. If I reflect it across the x-axis, what's it going to look like? Yes, sir?
You're just drawing a line through it.
You're just drawing a line through it, like this?
Yeah.
That's not a reflection.
Oh.
Reflection means I would actually fold my paper over and trace through that new point.
Oh, so it's going. Let me try again.
Okay.
Oh, you supposed to say a point? I thought
Yep.
we supposed to. Oh.
No, we want an ordered pair. We want a point.
Would it be 1 and
Would it be what?
1 and -4?
1 and -4. That would be a rotation around the origin.
Oh.
So here's my x-axis. This is where I would be folding it. So I would be folding it in half from the top over. And so I would see this point right here. If I folded my page in half over this orange line, yes, -1, -4. So here's my reflection over x.
Oh, yeah.
That's what I said.
He said that.
I thought you said +1, -4.
No,
And if I misheard that, I apologize. I really thought I heard both signs being switched, and so I apologize if that was a me thing, which it sounds like it was. So -1, -4. Which part of the ordered pair changed when we reflected it over x?
The y.
Yeah, here's my original point. When I reflected it over x, when I folded it in half, my x stayed the same, but my y changed signs. The y value changed signs. So thinking about a reflection across the y-axis, can you guys predict which value is going to change if I reflect across y? The x value is going to change signs. right, so if I reflect it across the y-axis, I would fold it in half like this. Where is it going to go to? Where would my point move to if I folded it in half across that vertical line? +1, +4, right here. This is a reflection over y. I don't have enough room for all those words. There we go. And so it's going to be at +1, +4. All right, we are going to be working with reflections, dilations. Dilations are stretches and compressions. And we're going to work with translations, left, right, up, and down. You're going to need your books out, so go ahead and pull those out for me. Yeah, I teach the same class 6 periods, so they'll just pass it back across for 6th, and then I'll collect the extras. Thanks for letting me know, though. Have you guys ever seen or been to Top Golf over in Fishers? So that Top Golf, they've got a couple different floors, and it's open onto this large space where you can practice your golf swing. And of course, they've got nets around the whole thing, so it's not flying out onto the highway. It's going to be page 57 when we get there. Yes, and you can turn it into the basket and still get credit for it. So I want you to imagine for a minute that we've got 2 different golfers, one right above the other, over there at Top Golf. They managed to hit the ball at the exact same moment, at the exact same angle, and the exact same speed. Is their ball going to travel in exactly the same way?
Yeah. No.
Why not?
It depends how they hit it.
Assuming that they hit it exactly the same.
Oh, still gonna change because they hit it on different. Let's say one of them is on one side and the other one's on the other side. Mm-hmm. It depends on the trajectory.
Yep. So I've got them like right above each other. One's on the first floor, one's on the second floor.
Oh no, it's not gonna go the same way because one's on the first floor, one's on the second floor.
What's going to be the only difference we see between these 2 golf balls?
The height.
Height.
No, what if they hit it the same way? It could go the same height. I'm trying to say it could go in different directions. Like one of them could spiral, the other one could go straight. See what I'm saying?
It is possible, but again, we're making a lot of assumptions here that they've got the same clubs, they're swinging at the same speed, at the same angle, and everything. The only difference is that one is on the second floor and one's on the first floor. These 2 parabolas are going to look almost identical, but since one person is higher than the other, we're going to see that parabola kind of shifted up there. Page 57. Page 57. So before we can talk about any kind of these transformations is the big umbrella that we use to talk about any kind of translations, shifting left and right, shifting up and down, any kind of dilation, a stretch or a compression, or any kind of reflection. In any way that a graph or an equation is different from the parent, we call that a transformation. So we need to talk about a couple different parent functions if we're going to talk about transformations. Parent function for a constant. A constant function looks like a horizontal line. It's just flat like this. Our parent for a constant is y equals 1, or f of x equals 1. I can always use my function notation interchangeably here. If I were to take this horizontal line and shift it up or down, would you notice a change? Would it look different than the parent if I take this guy right here and shift it up or shift it down? Would you see a difference? Yeah.
Oh.
If I take this horizontal line right here and I shift it up 2, same shape, different location. And I can see that change. What about if I were to take this horizontal constant and I were just to shift it a little bit to the right? Would you see a change then? On a line? Why would you not notice a change to the left or to the right on this straight constant line? It keeps going forever and ever to the left and the right. So if I shift it a little bit to the right, I'm not going to see it. If I shift it up or down, I would see that. This guy over here, this is my parent linear function. F of x equals x, or I like to write this in slope-intercept form, y equals x. This is my identity function because my input and my output are exactly the same. If I put 1 in for x, then y equals 1. If I put 7 in for x, then y equals 7. My x and my y always match. I wrote this right here in slope-intercept form. What's the y-intercept of that? What is the y-intercept? I'm thinking slope-intercept form, y equals mx plus b. What is this part? What is the b part? 0. If you don't see a number on the end, it is a 0. So what would the slope be? You can look at the equation or the graph for this one right here. My y, or sorry, not my y-intercept, my slope would be 1. Slope would be 1. Up 1, right 1. Up 1, right 1 to get to these points. And here's my y-intercept. Every line that you have ever seen or graphed or been asked to analyze is a transformation of this. It has the same beginning part. We have a y equals or a function notation equals like f of x. We have our slope. When the slope changes, that changes the pitch of my line, but it's going to stay a straight line. My y-intercept can change by moving up or down. So far, so good? All right. 2 others that we're going to look at, and these are both on page 57 there. That guy over there on the left looks like what letter? On the left, it looks like a V. This is my absolute value function. Absolute value function. Y equals, the way we write absolute value is with these big bars on either side. So we could say y equals absolute value of x, or f of x equals absolute value of x. That is what the parent looks like. Where is the bottom of this V? At which place? At 0, 0. We call this part right here the vertex. And on the parent, my vertex is at 0, 0. Always. Yes, sir?
How'd you get the y equals x again?
That is the equation for the parent function. I am giving you that piece. That is our parent. Any other V-shaped graph that I'm looking at, I would write it as a transformation of our absolute value. So we would take any other V-shaped graph and we would say, oh, it looks just like the parent, except it's been shifted to the left or to the right this much. It's been shifted up or down this much. Does that make sense? Okay. When I'm looking at absolute value, I can tell whether it's been shifted left or right, up or down, by looking at the bottom, at the vertex of that transformation. And I can count from 0, 0, because I know the parent touches at 0, 0. I can count how far I would need to go, left or right, up or down, to find the vertex of the new one. This one looks like what shape, or what letter? Looks like a U. What do we call this guy?
Parabola.
This is a parabola. My parabola, or my quadratic function, the parent for this is y equals x squared. Y equals x squared. Or we could use function notation. We could say f of x equals x squared. I can always replace my y with function notation. Means the exact same thing. Where is the very bottom of this u? Where is the bottom of the parabola? At 0, 0 again. This is still called the vertex. So just like with my absolute value, if I have any other graph that has a U shape to it, I can tell whether it's been shifted left or right, up or down by putting my finger on the origin and figuring out how far I would need to move to get to the vertex of that new parabola. Right? You guys ready to start looking at a couple examples with me? All right, we're going to look at example number 1 in your book. While you're looking at example 1, I want to talk for just a moment because there's 2 pieces when we're talking about translations. If I'm shifting things up or down, we call that part of our transformation the K value. Looking at these 3 right here, these have all been shifted which way, up or down? Up. If they have been shifted up, then our K value is going to be some number that is bigger than 0. So if I shifted it down, what do you think my K value would be? Less than 0. If we shift it down, K is going to be less than 0. So K is if I'm shifting things up or down, and I'll show you where we look for that or where we write that in our equations. If I'm going to the left or the right, we call that piece the H value. So K controls up and down, H controls left and right. If I've gone to the right, do you think that would be a positive or a negative? If I'm going to the right, my H value is a positive, something bigger than 0. If I've gone to the left, then it would be a negative, excuse me, a negative H value. All right. Yes, sir. Go to the nurse. Yes, give me just one moment. On example number 1, take a moment and look at this. The blue one is the parent. The orange one is the transformation. I want you to figure out whether you think this has moved left or right, up or down from the parent. See if you can figure out how far. All right. Let's see who wrote this down or who remembers from the previous page. And it was printed on there, so if you need to go and look, you can go back. What is the equation for my parent parabola? What is the equation for this guy right here? Y equals x squared. So f of x equals x squared or y equals x squared, same exact meaning. All right. From the vertex of the parent, right here, here's the vertex for the parent. Tell me how you would have to move to get to the vertex of the transformation. Would we go up or down to get there? Down. How far? 4 units. Would I go left or right? Left. How far? Left 2 units. H tells me how far left or right to go. If I'm going to the left, is that a positive or a negative? Negative. So H is negative 2. H controls things going left and right. K controls things going up and down. You said we went down 4. How do I describe that with just a single number? Negative 4. This is what my transformation form will look like for all of my different transformations. This F in the front, that just means the parent function. H will tell me about left and right. And K will tell me about up and down. Yes, ma'am. No, you're exactly correct. And to remember that, I actually call h, when it's inside the equation, I call that my opposite. So that I remember that in the equation, I see the opposite sign. And I want to show you guys why that is. So here they gave me the equation. I'm going to circle that in orange, actually. This is the equation right here for this guy. I see that down 4. That's my minus 4 right here. This is k, and it's telling me down 4. This guy right here, I see a plus 2, but we said this graph went which way? We said it went left 2, and so we described it as a negative 2. In the equation, it is the opposite of h. So if I see a plus 2, it's really telling me that h is a negative 2. And I'll show you how we can get that. If you're looking at the equation, how do you find that? What do you do with it? So inside those parentheses, it had x plus 2. To figure out what h is, I'm always going to take that and set it equal to 0. Always take it equal to 0. K, we just grab. I need to get x all by itself now. Heads up for me, guys. What would I need to do to both sides to get to get the plus 2 to cancel out? Subtract 2 from both sides. And when I do that, I get x equals what? X equals negative 2. This is h. I will always end up with x equals whatever my h value is. That tells me whether I went left or right in the x direction. So that's that left or right piece. How far and in which direction? We went 4 units which way? 4 units down. So down 4 units. Our h value is negative 2, and so we translated 2 units which direction? Left. So this this equation right here, and the graph that goes with it, g of x is equal to x plus 2 inside parentheses squared minus 4 is a translation of the parent function. 2 units left and 4 units down. 2 units left and 4 units down. Let's go look at example 2. Example 2, I give you the graph again, but we're going to take this graph and we're going to use it to write the equation. Is it a parabola again in example 2? Are we looking at a parabola like this one? What do we call the V-shaped graphs? Absolute value. Absolute value. For the parent function, the equation is what? Y equals, or f of x equals, yeah, x with the 2 lines on either side. We have those absolute value bars on either side with the x inside. The vertex has been shifted both vertically and horizontally. Vertically is going to affect my k. Horizontally is going to affect h. Start from the parent. Where's the vertex for the parent? 0, 0 for the parent. We start here. Tell me which way to move to get to the vertex for my transformation to get up here. Up 2 and over to the right 1, yes. So we went right 1 and up 2. So what is my h value? H is 1. And my k value? 2. I need to get it in this form right here. This piece right here in my equation will always be the opposite sign of what I saw happening on my graph. So if on my graph I saw it moving to the right, what will I see in there with x? Will I see a plus or a minus? A minus. If I'm going to the left, that's the minus direction, right? But in my equation, I'm going to see the opposite sign. So I would see what there? I would see a plus. Here's another way that we can go about finding what's going to be in there. I'm going to start with x equals h. We said that our h value is what? H is 1. I need to get this equal to 0. To put it back in my equation, it has to be equal to 0. So what would I do to cancel out a 1? Subtract it from both sides. And so then I have x minus 1 equals 0. This goes in my equation. So when I go to write my equation here, g of x equals, what do I need around the x minus 1? What do I need on either side of it? I need that absolute value bar, the distance. X minus 1. After the absolute value is where you find k. I always think about k like it's a little sibling that wants to tag along with the older kids. It is always left out. It is always at the very end. It never is inside with x. It's always tagging along behind. Hey, don't forget me. And we always just take it the way it is. Did we go up or down here? Up, how many units? 2. So on the end, I put a plus 2. Ibrahim, you with me? Nope. Sit up with me. Stay with me. I want to look at a couple examples to practice this same skill, but that aren't in your book. All right? So you'll have to look up here. I've got some multiple choice. We want to try to figure out which ones work. You guys ready? Here's my transformation. This is a transformation of y equals x. Where would I look to see if it went left or right at all? I'm going to look inside these parentheses right here. If I see x minus 2, I always take that and set it equal to 0, and I have to solve this for x to figure out whether it went to the left or to the right. What would I do to get the x all by itself? We're going to add 2 to both sides. And so I would get x equals what? X equals 2. Is that a positive or a negative? Positive. So we went which way? We went to the right. Remember, inside my equation, what I see right here, This is the opposite sign of what it's going to come out to be every single time. So we went 2 units to the right. What is K? 1. K is always tacked on the end. Would that be shifting up or down 1? Up 1. I need to figure out which one of these graphs took the parent function and shifted it to the right 2 and up 1. That parent function looks like this. I got to figure out which one of these shifted it to the right 1, or sorry, to the right 2 and up 1. Let's look. D, I'm going to pick out a point. If I take this to the right 2 and up 1, is that a point on my line? No. What about if I go back over here to A? To the right 2 and up 1, is this point on my line? Nope. To the right 2 and up 1. To the right 2 and up 1. That one has a point on my line. Correct one is C. I had to put my parent on the graph so that I could count over right and up to figure out which one this was. Let's try one more with a parabola. This one's a little bit easier. What does the parent look like again? Yep. Y equals x squared. Where is the vertex for the parent at? 0, 0. Parent function looks like this. All I really need to know about it, though, is where that vertex is. The vertex is at 0, 0. How would I need to move to get to the vertex of this transformation? Down 4. And which way? Left 3. Going down 4, is that H or is that K? That is K. Where do I always find K? At the end. So which 2 can we throw out because they're definitely wrong? C and D. This is my K value. -4, yeah. We said our K value was -4, so this has to be option B. But that says +3, and we said we were going left 3. How does that work out? Yes. Remember, what I see right in here, if it's in the equation, it is going to be the opposite sign of what I see on my graph. So if I see a +3, that really means go left. I can set this equal to 0 to see it happen. X +3, set it equal to 0. I would subtract 3 from both sides. X equals -3. There's my H. That tells me left 3. So far, so good? We've got one last thing to touch on. Down at the bottom of page 58. Heads up for me, guys. Almost done. I wish I had, my daughter has this bouncy ball that's kind of really easy to squish. It has like little knobs all over the outside. Have you guys ever seen those? You can get them out of like some of the crane games and stuff.
Oh.
It's stretchy almost like a balloon is, except it's a perfect round ball. So I think about that when I'm thinking about stretches and compressions. If I put a hand on top and a hand on bottom, and I stretch this vertically, what's going to happen to the sides?
It's going to slim up.
Yeah, it's going to get skinnier, it's going to get narrower. That is a vertical stretch because I pulled it this way and all the rest of it got sucked in this way. That's going to happen whenever my A value, and I'll show you where that lives, whenever the A value is a number that is farther away from 0 than 1 in either the positive or negative direction. So if I see a whole number like 2 or -7, it doesn't matter whether it's positive or negative, it's going to be a stretch. What would happen if I put my hands on either side and I squished it? What happens to the sides?
It's going to get fat. It's going to get fat.
It's going to get fatter, it's going to get wider. That is called a vertical compression because I'm squishing it this way. When I compress it vertically, I'm going to see my graph get wider. Like green, if you look at the parabola and the absolute value, it got wider, it got fatter. When my A value is in between 0 and 1, positive or negative, doesn't matter. But if I'm seeing a decimal or a fraction, that's going to be a compression. Last thing we need to touch on before we look at our very last example is reflections. If I take my whole function and I multiply it by -1, it's going to flip it over the x-axis. It's going to take whatever y values were positive and it's going to make them negative. If I put a -x in, that will reflect it across the y-axis this way. Let's look at our very last example. Example number 3. What kind of a shape do I have? I've got two different lines. One of them is which color? I've got a green one and I've got a blue one. Which one is the parent? The blue one is my parent. We're on page 59 now. Blue one is my parent. Y equals x. They've given me the equation for the green one here. They gave it to me right here. G of x is a linear function, so the parent function is f of x equals x, or y equals x. Remember, function notation and y are interchangeable. All right, so they tell me that g of x, which I have the equation for up at the top, is -1 times my fraction. What was the fraction part? Yep, I already have that negative. I want the 2/5 times my parent. So I have -1 times 2/5 times x. I want to try to identify these different values now. What is the value that we're using as the A value? So look right up above. Here's the -1. Here's the A. Here's the parent. 2/5. A is 2/5. If I put that in my calculator, would that be 0 point something, or would it have a whole number and then point something? Grab your calculators, let's check it. 2/5 is a decimal. Starts with what? Yeah. This is 0.4. Because it starts with a 0 here, that tells me that it's going to be a compression. Numbers that are in between +1 and -1. If it would fall within those numbers on the number line, it's going to be a squish. So if I take any fractions they give me and I pop them in my calculator, and I get something that starts with a 1 point or a -3 point, whatever, that's a stretch. If it starts with a 0 when I put it in my calculator, that's a squish, that's a compression. So this one's going to be compression or stretch? Compression. This function is compressed vertically. And it's also been reflected. Reflected over x or over y? Over x. It's been reflected over the x-axis. That's what this -1 is doing right here. If you see a negative at the front, that is going to reflect it over x. Reflects it over the x-axis. So far, so good? Reflects over the x-axis. Anytime you see a negative right here. Reflections over the y-axis would be if this x was negative. If I replaced that with a negative, that would reflect it over y. If you see the negative out in front of these pieces, it's going to reflect it over x. We're going to keep working on transformations tomorrow. We'll work with this some more, but I'm going to shut it down here for today. You guys have one last homework assignment for this module. When is your test again? Does anybody remember? This Friday. This Friday. I will be passing out a paper test review for you. My goal is to have it in your hands by tomorrow. If the printer disagrees with me, it'll come out on Wednesday, but I should have it in your hands by tomorrow. Working through this paper review is going to be the best practice I can possibly give you for the test. There will not be anything on the test that is not covered on the review. The review will be slightly harder than the test.
Can we use the review on the test?
You cannot use the review on the test. But it is really important that you work through that review, because if you can work through the review with your notes, with your classmates, with me, until that makes sense, then the test should be okay. Even though you're doing it without notes, you have worked through harder but similar problems. You should be ready for the test. If you don't do the review, the test will be very hard. You need to do the review to be prepared for the test. I will post all of my answers for the review as well, showing all my work and how I'm going through this. That will be posted on Canvas for you guys. We're going to spend Wednesday and Thursday in class together reviewing for this test. Wednesday you're going to have as more of an independent review day, where you can work on the review, work with a partner, ask me questions. Thursday, I will take questions and go over any pieces of this that you guys want to see. All right? Sound reasonable? Okay. Your last homework assignment will be due on Wednesday. It's pages 63 to 65. I've got the problem numbers up here. You guys can work on that. You had a homework assignment due today too, didn't you?
Yeah.
Yep. The 1-6 is due today. Any homeworks that you have not turned in from this module, if you get them in before Friday and you pass the test, 60% or higher, turn them in before you take the test, get a 60% or higher on the test, you'll get full credit for all those homeworks. So even if you miss some points, I'll take them up to 100%. That is only if you've done them before the test. The homework is supposed to prepare you for the test, and I'm trying to reward you for that, okay? Get them turned in to me before Friday. Work on that test review. I'll be looking at the review for completion when you guys take that test.